The replacement of wheels happens often. The change of winter and summer tires is recommended 2 times a year. Furthermore, it could happen that you have to change the wheels because of a puncture. However, a wheel change is a well-known process. The proper execution of the procedure consists of many crucial steps. Do you know, for example, why it's so important to tighten the wheel studs with the prescribed torque? And why is it essential to follow the proper tightening order? Join us, and Virtualitica could provide answers as to the whys. The wheel studs can be fixed according to standards by a conventional wrench after the car is let down. You must not over-tighten the stud or kick the wrench. In the simulation, you can see what happens if the bolt is overloaded. The prescribed 120 Nm torque does not cause any plastic strain on the wheel stud. What that means is that the part isn't damaged and remains reusable. If you use more torque than what is prescribed, plastic strain and damage will be seen in the thread and on the stud. The best solution is to use a torque wrench. With a torque wrench, the prescribed torque and the proper tension force can be set easily. The simulation shows well that the tightening torque, which is defined by the manufacturer, does not cause damage, but secures a sufficient retention force. It's important to note that the prescribed torque can vary from one manufacturer to another. Set the torque to the value defined by the car's manual. A common mistake during a wheel change is to tighten the bolts in circular order one after the other. It would be in bad form to continue tightening each bolt in seconds. The following simulation shows why doing it that way is a bad idea. The animation shows the contact pressure on the wheel hub in the environment of the studs. The difference in pressure can be seen despite an identical tightening of torque. In other words, the pressure distribution will be uneven. This unevenness causes inhomogeneous support and the non-uniform deformation of the wheel hub. This phenomenon can affect the safe driving and comfort and the function and wear of the disc brakes. Furthermore, it can negatively influence the lifetime of the wheel bearings. In order to avoid this phenomenon, the tightening of the studs should be done diagonally, so that the assembly is always continued with the opposite bolt. Let's see why a diagonal order is beneficial. This simulation shows well that in the second case there are much better support and more homogeneous contact pressure between the parts. The formation of the wheel hub will now maintain a fully symmetric hub, which will also mean a smooth ride. Let us summarize what we have seen. It is important not to overload the wheel studs, because the part will be damaged, but the retention force won't be higher, and the consequences can cause driving security risks. The use of a torque wrench is recommended, and the specifications defined by the manufacturer should be followed. Furthermore, it is crucial to tighten the bolts diagonally, and not counterclockwise in order to get even contact. In the automotive industry, almost all parts of a car are simulated by engineers before a serial production. With these virtual tests, reliability and safety are secured. The wheel studs and wheel hubs are no exceptions. If you're interested in viewing one of our simulations from everyday phenomena like this one, follow us on Instagram, LinkedIn, or YouTube.